The code is quite similar. Also, the process is quite similar to insertion in the middle of a doubly linked list. So let's get into it. Firstly, deletion in the middle would mean not by index like 0, 1, 2, 3. You can of course go by index, but I'm gonna go by the elements. Say I want to delete wherever a 3 exists, or wherever a 5 exists, or wherever 1 exists. This is called deletion in the middle. So let's assume I want to delete where 3 exists. So the step 1 would be, you're gonna make a temporary node called D and make it equal to head. Okay, it's actually a pointer, not a temporary node. Sorry, I keep saying temporary node. It's a pointer. So you're gonna make a pointer, make it equal to head, and then once you make it equal to head, you're gonna make it loop or traverse the linked list. Okay, so you're gonna keep traversing it until it finds the 3. Okay, and just before it finds the 3, you want to make it stop at that node. Okay, so it's gonna stop one node before the node that it's gonna delete. So here it found the 3. Okay, so this is step number 2. You're gonna make it loop and make it stop one node before the one you're deleting. Okay, this was step number 1. Step number 3 would be, so basically the node that you're trying to delete, you're gonna call it, you're gonna make another pointer and make it equal to that. So this is another pointer and I'm gonna call it del. Okay, D's next is gonna equal to del. Okay, del meaning the one we're trying to delete. After doing that, the next step is that you're gonna say del's next value is gonna be equal to the next value of del, meaning this arrow right over here is not gonna point to del anymore. It's gonna point over to this here. That's step number 1. So you're breaking a link here. Step number 4 is breaking the link and re-establishing a new link. Then step number 5 is that you're gonna say del, or this this node's next value, and the previous of that, basically when you're referring to this node over here, okay, its previous value, you're gonna break this link and you're gonna bring it over here, make it point there. Don't worry about this arrow here right now. This is here. Okay, because once you delete this node, then its arrows are also gonna be destroyed. By the way, this is step number 5. Step number 6 is our classic one, where you delete. The moment of truth, the moment we've all been waiting for. Okay, deleting the node 6. So yeah, that's how you delete in the middle. Now there's only 2 nodes left. So firstly, we have to write some edge cases, of course. One edge case is if our linked list is empty. If that's the case, then you just want to return as usual. The next would be if it has a single node. If that's the case, you're going to make tail equal to, actually no, hold on a moment. We had to put our data inside here. So basically the data that we're trying to, or the element that we're trying to delete. So that's our, I'm gonna rename this to element. Okay, now I want to check if the not single node. Okay, I'm gonna say if head dot data is equal to element, meaning if our head contains the element that we're trying to delete, and if that's the case, then I want to do a delete at head. So I'm just going to call that function out. Once that's done, then I'm just going to return. And of course the del at head function is going to handle if it's a single node, so I don't need to specify the single node condition. Okay, so that's just some of the edge cases. There's one more edge case, which is like if the node that you're trying to delete is stored at the tail, or is the tail node, or is maybe just one node before the tail node. So we're gonna handle that. But firstly, we're gonna make we're gonna follow a bit of steps here. One step. Okay, so we can proceed with step number 1. Step number 1 was to make a temporary node called D, or a pointer, sorry, and make it equal to head. After making it equal to head, step number 2 is to loop it, and you want to loop it in such a way that it stops one node before the one you're deleting. If it hasn't reached the last node. Okay, that's one condition. If you don't understand this, you can watch my insertion in the middle video, you'll understand this condition there. I explained it quite thoroughly. Then you want to check if our for the classic condition, if the data, okay, so if our these data is equal to element, and we want to end the loop if it's equal to element. So we want to run the loop if it is not equal to element. Okay, but before we want to stop one node before, we're going to put a next here, and then we're going to put the data. See, I hope that makes sense, because if I say d dot next, okay, if I say d dot data is equal to element, it's gonna stop at 3. Okay, so d is right over here, it's gonna hop over to 3, and d is gonna come over here. That's not what I want, because I want to delete this node, so I don't want d to be equal to that. I want d to stop one node previous to that. That's why I put a next. So it's gonna come here, it's gonna say d dot next, which is this node, dot data, and it's gonna see the 3. Okay, and it's gonna check if it's equal to element, which is 3. So yeah, if it is equal to it, then it's going to come out of the loop. Now once we do actually exit the loop, I want to check whether the loop terminated because of this condition, or whether the loop terminated because of this condition. Okay, so I'm going to have an if statement checking if the loop terminated because of the first condition. So how do I do that? If temp.next is equal to null. Okay, what does that mean? It means that the element wasn't found. So I'm going to say, okay, basically the type of element you're trying to delete is not found, so just return. Okay, then I want to check if the loop terminated because of the second condition. How do I do that? I'm going to check if its next value, remember we say d dot next, I'm going to say d dot next dot data. You can also actually no, don't do d dot data, let's just do this dot next, because this condition basically is checking. It's not really much to do with this if it found the element, because this condition checks if it found the element. This condition checks if it found the element, but it found it at the tail, because d dot next means that you are at the second last node, and if you're at the second last node, it's because the last node is where your element is, and you have to delete the last node, meaning you have to delete the tail. So I'm going to say del at tail. Remember, this is one of the edge conditions that we're trying to code. Okay, now once we've covered all of these edge cases, I just want to continue with our usual steps. Alright, which is step number 3, I suppose. Right now we've done step number 1, where we make a temporary pointer. Step number 2, we make it loop, and then step number 3 is to delete it, or actually not delete it, to create a temporary node. I'm going to equal to d dot next. Okay, that's step number 3. After doing step number 3, remember del is the node that we're deleting now. Okay, so then we want to do d dot next is equal to del dot next. This is step number 4. What this line of code does is the following. It says d dot next, right? So it breaks this link right over here, and it establishes this link. Okay, then once that's done, I want to say that I want to do step number 5, which is del dot next dot previous is equal to this, not head, is equal to d. Okay, remember it's a doubly linked list. So I'm going to say del dot next dot previous is equal to d. Okay, once that's done, then that's step number 5. Step number 6 would just be to delete our del node. And where am I coding? Should have been coding here. This should have been here.